Okay, good day, seniors. This video is about the Vieta's theorem or the Vieta's formulas. This theorem gives you the relationship between the roots of a polynomial with its coefficients. Now look, you have this polynomial ax cubed, bx squared, cx plus d. You know that a, b, c, and d are called coefficients. Now if you have r, s, and t be the roots of this polynomial, therefore, x minus r, x minus s, x minus 2 will be the factors. When you multiply this, it will be like this. And this 2, this 1, and this 1, they are basically the same. So meaning, you can get the relationship r plus s plus t is equal to, because they are both the coefficient of x squared there, you have negative b over a, rs plus rt plus st, c over a, rst, the product of the roots, be negative b over a. Again, R and S and T are the roots, A, B, C, and D are the coefficients. Now look at this polynomial right here. Even without solving for the roots of this, I'll put the three formulas of Vietas here. Even without solving for the roots of this, let R, S, T be the roots of this polynomial. Then you know R plus S plus T is negative b over a. You have here a is equal to 1, b is equal to negative 9, c is 23, and d is negative 15. So r s, t are the roots of this polynomial. We don't have to solve for it. If we're just after the sum, r plus s plus t would be negative b over a, and that's negative of negative 9 over 1, which is 9. Then you are asked after the product r, s, and t, r times s times t of the polynomial, it's just negative d over a, and it's negative of negative 15 over 1, and it's of course 15. Now, the sum of the products of the roots taken 2 at a time, rs plus rt and st, is c over a, and the rs plus rt plus st would be c over a, and that's 23 over 1 or 20. Actually, I solved this can be easily solved, the polynomial. You can easily factor and do it yourself. You can get the factors of x minus 1, x minus 3, and x minus 5. So the roots, of course, would be 1, 3, and 5. If you will just check, remember that we did r plus s plus t even without solving, and now you have the roots here. 1 plus 3 plus 5, it's 9. 1 times 3 times 5, it's 15. And 2 at a time, 1 times 3, 3 plus 3 times 5, 15 plus 1 times 5, 5, it's 23. So that's actually the very basics of the Vieta's formulas. So let's answer a simple problem. 2 roots of 6x cubed plus wx squared plus yx plus 12 equals 0 are negative 4 and 3/2. Find the third root, w and y. Now look, we have here, of course, the polynomial would have a equals 6. The coefficient of x squared, that's actually our b. So you have w. The coefficient of x is actually c, it's equal to y, and then d is equal to 12. So we are given 2 roots, negative 4, 3/2, and the third root that be r. It's actually one of the unknowns, r. So the unknowns are w, y, and r. Again, recalling that if we have 3 roots, r plus s plus t, the sum of the roots would be given by negative b over a. The product, r, s, t, would be given by d over a. Negative b over a, c over a, this would be negative d over a. Again, let's check that it's negative b over a, c over a, and negative d over a. The signs will just alternate as the polynomial goes larger in degree. Now look, rs is negative d over a. Good thing we have these 2 roots given, negative 4, 3/2, and r. So multiplying them, so negative 4 times 3/2 times r. It's negative b over a, and it's actually given in the problem. It's 12, negative 12 over 6. That's negative 2. So solving for r, that's one of the unknown. Negative 4 times 3 halves would be negative 6. So negative 6r equals negative 2. So obviously r is negative 2 over negative 6, and that's simplifying it would be 1/3. We have 1/3. Now we get w. Now we know that we now have the complete roots. Okay, we now have 1/3. So erase this part. Now we can get w because the sum of the three roots, negative 4 plus 3 halves plus 1/3, negative 4 plus 3 halves plus 1/3, is actually negative b over a, and b is this w, so negative w over 6. A, of course, is 6. Negative 4 plus 3 halves plus 1/3. Wait, I'll just I'll use the calculator, help me out. Negative 4 plus 3 halves plus 1/3. That's negative 13 over 6. So this is negative 13 over 6, and it's equal to negative w negative over 6. So obviously w is positive 13. Right? And the last missing variable, y, solving for y, and it has something to do with the coefficient of the linear term x going back to the Vietas. It's c over a, and has something to do with the product of the roots taken 2 at a time. It's not a problem anymore. Erase this part first. Because we have the 3 roots. So we have here rs plus rt plus st, and it's equal to c over a. So we have negative 4 times 3 halves taken 2 at a time. This would give us negative 6. 3 halves times 1/3, that's actually 1/2. And then negative 4 times 1/3, that's negative 4/3. So adding the 3 up will give you this. And it's actually c over a, or y over 6. Then again, negative 6, calculator, negative 6 plus 1/2 minus 4/3. You get here negative 41 over 6. And it's equal to y over 6. So y is equal to, obviously, same denominator. The numerators are the same, negative 41. So we have this, we have w, and we have this is r, what we got earlier. And that's done. Now just to check, the polynomial would have to be 6x cubed plus wx squared, that would be plus 13x squared, right? 13x squared, x squared there. Yx, that would be minus 41x. And then plus 12. Then equals 0. There. This is the polynomial. I just want to check whether the roots are negative 4, 3 halves, and 1/3. And of course, if the roots are those roots, we are correct. We have 6, 13, negative 41, 12. So the roots are here. C, then it's 1/3, negative 4, and 3 halves. So we are correct. Now, I'll just have to make another video showing more problems, harder problems. So for now, I want you to just remember these basics. the sum of the roots r plus s plus t is negative b over a. The product of the roots negative b over a. Sum of the product of the roots taken 2 at a time c over a. And this is actually a good problem, right? So from the last one, 12 over 6, we got the third root, and from there, we just applied the Vietas to find w and okay, now let's, I have one more problem actually, but I'll leave this to you. Try to do this yourself. Okay, there are actually 3 problems, another problem here, but I'll just leave this to you for practice. So that's it for now. Peace out.